chapter on polygons, which you worked with triangles forever. Those are polygons, right? We're going to extend it to more than just triangles, though. Number one, polygon, yes or no? Yes. No, and the pause is no. What's the issue? That you can't have any curves on a polygon. How about number two? No. Nope, it's curved. How about three? Yes. Yeah, three is fine. It's made up of straight segments, right? It's closed. How about four? No. Nope. You have gaps here. It's not a closed figure. It overlaps. You can't have that happen either. Five should be a. And six? Nope. What's the issue on six? It's open. If this was connected here, we'd be fine, right? But it's not connected, so it's a no. Alright, what do we call a three-sided figure? Triangle. Four-sided. Quadrilateral. And if you put square or rectangle or rhombus or something like that, those are four-sided figures, but we want the most generic name, which is quadrilateral. Six-sided, hexagon. 9, nonagon. 10, decagon. How about 12? Yeah, think dose is 2 plus 10. Dodecagon. And then there's engon. The engon could be any number of sides. And really, once we get past 12, like if I had a 15-sided figure, I just call that a 15 gon. Yep, 13 would just be a 13 gon. And it's not that there isn't prefixes for them. Like 15, you can do a pentadecagon. It just gets to be too much, right? So once you get past 12, then we just put the number of sides dashed on. Gon means sided, 15 sided. Okay, backside. Number 7. How many sides? 5. So it's a pentagon. Convex or concave? Convex. Or 8 is also a pentagon, but it is concave. So it's caved in. 9 has 6 sides, so what do we call it? Hexagon, and it is concave. Alright, and then at the box. On 10, if I look, all of the sides are the same, and all of the angles are the same, so that makes it what type of figure? Regular. This one, only the sides? Yeah, equi means equal, right? Lateral is sides, equal sides. And then the last one is what? Equiangular. The sides are different, but the angles are all the same, so equiangular. I'm going to let you keep that. I really should have put it in your notes because there's definitions that you might need to refer to, so keep that, all right? We are going to watch the video that you were supposed to watch, just because there were issues with viewing it. So if you already watched it, you just see it a second time, you'll be fine. All right, you guys ready?
Here we'll find a formula for the sum of the angles in different polygons. For example, here's an octagon, meaning it's a polygon with 8 sides. Let's label all the angles in this polygon. What do these angles add up to? To find out, let's start with a simpler polygon, like a triangle, which is a polygon that has 3 sides. What's the sum of the angles in a triangle? If you're not sure, click down here.
What do the angles add up to? 1/8. Oh.
Exactly. The angles in every triangle always add up to 180 degrees. Next, let's look at quadrilaterals, which are polygons that have 4 sides. Here are a few examples of quadrilaterals. Let's take a closer look at the rectangle over here. Rectangles are quadrilaterals whose angles are all right angles, meaning they all equal 90 degrees. What's the sum of the angles in a rectangle.
Oh, and you guys should flip the page, sorry, in your notes, which looks like this. Let me go ahead. In your notes packet, here's our overview of the whole chapter, right? Things that we'll learn throughout the chapter. Next page, you don't have this. Polygons, which we're going to study, are they used? Like in this room, do you see polygons if you look around? Yeah, lots of things are made up of straight segments. One thing they're used in that maybe you didn't know, video games. In designing the game, it starts with a polygon, and then they can add the lighting and the shading and the actions and everything like that. I'm not going to read through all of this. As technology has progressed, are we listening? The polygon, less probably of an impact because we have other things that can generate our images. But either way, when you look at 3D graphics, there's polygons in the background, whether you know it or not. Here's some other ones. On this guy, again, if you look behind the shading and the lighting and all of that, there's polygons. This is basalt. When it cools in the shape of pentagons. This is the Pentagon. What are these things? Yeah. When you go out, like if you can see a snowflake, like you don't necessarily need to catch it, but in your car when they land on the windshield, look, see if you can see this hexagon. The longer they have to fall, the more intricate they get. What shape is this here? Hexagon. Hexagons and pentagons, they're pretty common. Chemical structures, here's a pentagon and a hexagon. Flower, pentagon, what's this thing? The octagon. This chemical structure is actually caffeine. Okay, so when you look at caffeine, if you can break it down to its chemical structure, those polygons exist. Okay, you have this page in your notes. As we watch the video, I want you to fill in as much as you can. So we've already done a triangle. How many sides on a triangle? 3. How many triangles? 1. What do the angles add up to? Okay, we'll watch the rest of the video and then see if you can fill in. In this quadrilateral, if all the angles are 90, what's 90 times 4? 360. Okay, keep listening.
So because every rectangle has 4 90-degree angles, the angles in a rectangle always add up to 360 degrees. Now, with this interactive graph, you can make any quadrilateral you want by dragging around these 4 corners. The quadrilateral's 4 angles are also shown up here, and for this quadrilateral, they add up to a complete rotation. In other words, the 4 angles in this quadrilateral add up to 360 degrees. Try making a quadrilateral whose angles add up to something other than 360 degrees.
So if I move this around, watch this total, or that circle. Do we ever get a measure that's not? Oh, this is delayed. No matter how I shape this, if I make it look like a kite, could actually make it concave. A big delay. Still 360, right? So no matter what on a 4-sided figure, angles are always going to be 360. And there's a reason.
So it seems like the angles in every quadrilateral always add up to 360 degrees. So these angles over here add up to 360. These angles add up to 360. And these angles also add up to 360. One way to show this is true is to divide each of these quadrilaterals into 2 triangles. So this quadrilateral can be divided into 2 triangles like this. This one can be divided into 2 triangles like this. And the rectangle can also be divided into 2 triangles. Every quadrilateral can be divided up into 2 triangles. And as you know, the angles in each triangle add up to 180 degrees. Therefore, the angles in every quadrilateral must add up to how many degrees again?
Yeah, 180 times 2 or 2 times 180, 360 degrees.
Right. The angles in every quadrilateral add up to 360 degrees because every quadrilateral can be divided into 2 triangles. Next, let's look at pentagons, which are polygons with 5 sides. Every pentagon can can be divided up into the same number of triangles. What is that number? When you're dividing up the pentagons, just make sure the triangles don't overlap. And feel free to ask for a hint if you need it.
Yeah. You guys picture the 3. I could go show you, but he'll do it in a moment. So here we go.
Exactly. Every pentagon can be divided up into 3 triangles. For each of these pentagons, there are a few different ways to divide them up. But here's one way for this pentagon. Here's a way to divide this pentagon. And here's a way to divide this pentagon. So if every pentagon can be divided up into 3 triangles, and the angles in each triangle add up to 180 degrees, what must the angles in every pentagon add up to?
Okay, how'd you get it, though? Yeah, 180 times 3 is 540.
Precisely. The angles in every pentagon add up to 540 degrees. Let's see if we can find a pattern. Let's look at polygons that have 3, 4, 5, or 6 sides. And here are the names for these polygons. Let's write down how many triangles you can divide each polygon into. A triangle is already made up of nothing but triangles, so let's say we can divide it up into 1 triangle. You found that every quadrilateral can be divided up into 2 triangles, and that every pentagon can be divided up into 3 triangles. It turns out that every hexagon can be divided into 4 triangles. Do you notice a pattern between the number of sides in a polygon and the number of triangles you can divide it into? Now suppose you have a polygon with n sides, which is also known as an n-gon. In terms of n, how many triangles can every n-gon be divided into?
N times,
Yeah, if you look, like here where there's 4 sides, 2 triangles, 5 sides, 3, how do you go from 5 to 3? 5 to 3 minus 2. So it looks like you take n, which is the number of sides, minus 2.
Right. Every n-gon can be divided up into n minus 2 triangles. Now let's look at the sum of the angles inside these polygons. The angles in every triangle add up to 180 degrees. The angles of every quadrilateral add up to 360 degrees. And the angles of every pentagon add up to 540 degrees. Since every hexagon can be divided up into 4 triangles, and each triangle has 180 degrees, every hexagon has 4 times 180, or 720 degrees. Now you said an n-gon can always be divided into n minus 2 triangles. So what's the sum of the angles in an n-gon?
Okay, so if there's this many triangles, right? How many degrees in every triangle? 180. So how are we going to figure out what our answer would be? And when you go to a variable versus having exactly 3 sides, 4 sides, 5 sides, we come up with the formula, right? I'm going to take that n minus 2, right? That will give me the number of triangles. And every triangle is how many degrees? What do I do with that 180? Times. I guess I need to hit times on here. Whoops. Does that make sense? Up here we did 4 times 180 to get 720.
Precisely. So if a polygon has n sides, then the sum of its angles is n minus 2 times 180 degrees. Let's take this formula for a spin and try it out on a sample problem. First, let's say what regular polygons are. A polygon is regular when all the angles are equal and all the sides have equal length. So here's a decagon, which is a polygon with 10 sides. And this is also a regular decagon because all the sides have equal length and all of these angles have the same measure. So what's the measure of one of these angles, like this one over here? You'll need this formula to figure it out. And if you get stuck, click down here.
You guys figure out this one that watched the video? Can we figure out?
where we got stuck.
Okay, so can we figure out what all of these have to add up to? How many sides are there? 10. So then I'm going to do 10 minus 2 times 180, right? Which is 8 times 180, which is what? punch it in for them. 1,080.
Wait.
Or is it 1440?
That's 6. That's
1440. Okay, and that's all of them. So what if I just want this one? Then divide. Do 1440. There's 10 angles. They're all the same. When we divide by 10, what do we end up with?
We end up with what? 144. Yeah. Okay, so there's your end.
Nicely done. Each angle in a regular decagon is 144 degrees. And in any regular polygon with n sides, the measure of each angle is the sum of all the angles, which is n minus 2 times 180 degrees, divided by the total number of sides, which is n.
Okay, so did you guys fill this in?
what's in the first one that we have to
Oh, the top part?
Yeah.
Yeah, we'll fill that in.
Such a delay at home. Polygon has to be a closed figure. So closed. Formed by 3 or more line segments, or if you just put segments, that's fine. And those segments are called what? Yeah, they're sides. Okay. The points on a figure really hasn't come up yet, but these points, we did that when we did triangles. Each one's a vertex. The points are vertices, and then you have sides. Okay, so triangle, you should have 3 filled in. One triangle, 180 degrees. Quadrilateral, how many sides? 4. How many triangles do we get? 2. 2 times 180 is 360. If we have 5 sides, how many triangles? 3. 3 times 180 is 540. Hexagon has how many sides? 6. How many triangles? 4. 4 times 180 is heptagon. How many sides on a heptagon? 7. Hept is your prefix for 7. 7 minus 2 means there's 5 triangles. 5 times 180 is what? 900. Octagon, how many sides on an octagon? 8. How many triangles would I end up with? 6. 6 times 180 is 1080. Nonagon, how many sides? 9. So then 7 triangles. What's 7 times 180? 1260. And then we have a decagon. The table stops at a decagon. We could put dodecagon on there. An 11-sided figure is a undecagon. 10 sides, right? 8 triangles. What's 8 times 180? Okay. And then we got to our general formula. If we have n sides, right? To get the number of triangles, we always subtract 2. So n minus 2 times what? 180. And again, this n minus 2 is the number of triangles, right? There is logic to the formulas, right? We start with specific, work to a variable, that gives us a formula. And there's a reason that n minus 2 is always the number of triangles. 180 degrees in every triangle. All right, let's do one. 15 gone. How many sides do we have? 15. How many triangles? 13. 15 minus 2 times 180. And on your notes, I would write this out. 2 weeks from now, when we review and test, at least you can look back and see why we have the answers we have. What's 13 times 180?
2,140.
340? Okay. We're gonna skip to 3. I don't think we need to do all of these. I have a 48 on. Guess what? I'm gonna take that 48, that's the number of sides, subtract 2. Which gives us 46. What's 46? Times 180. 80 to 80. Could you draw a 48 gun?
Yes.
You could. Is it going to be easy? What's the issue with it? Yeah. And as you try to draw it, it ends up looking like a what? Circle, right? Unless you draw it concave. If it can be concave, like you can zigzag all the way around. You could have 24 on top, 24 on the bottom. But if it has to be convex, it ends up looking circular. So as you increase the number of sides, it starts to look like a circle. Okay, flip page. We will not finish all of the notes today. We'll do this page and then we'll save the rest for tomorrow. Okay? You have 8 problems to do. Okay? When we get to your son. Lateral, equal means equal. What does lateral mean? Sides. So if a polygon is equilateral, all the sides are the same. Equi is angular mean angles. And if you have a figure that's both, we call it what? Yeah. And then we have less writing, right? I don't have to write out that it's equilateral and equilateral. Some of the interior angles, we learned that it's n minus 2 times 180. And that's, again, for some. Today won't be so bad, but tomorrow when we mix interior and exterior, you have to be careful on your directions as far as which formula or process you do. These first few, though, find the sum of the interior. So we're just going to use n minus 2 times 180. And I would try and do it without looking back. Heptagon, how many sides? 7, because eventually you won't be able to use your rules. But hopefully you remember the process. What's 5 times 180? 9. That's it. That's the sum. We're done. Nonagon, how many sides? 9. Non, think 9. So how many triangles? 7. And 7 times 180 is what? Okay, how about Dodecagon? How many sides? 12. Think do's 2 plus 10. 12 minus 2 means I have 10 triangles. 10 times 180 is 1800. Okay. Given the sum of the interior angles of a regular polygon, find n and name the polygon. What does n stand for? Yeah, this is the number of sides. So our goal is, can we figure out how many sides if we know the sum? And on this, you just have to think, like, we're working backwards. How do I get to this number? I would have had to plug into n minus 2 times by 180, and then I would have got 540 as an answer. So we just have to work backwards. How do we work backwards? What should I do? Before that, undo the 180. So to undo multiplying by 180, I'm just going to divide by it. You could distribute if you wanted to get rid of parentheses first, but we can just divide by 180. So then n minus 2 equals what? About 3. Right, 540 divided by 180 is 3. And that's the number of triangles in my figure. Now I have to undo that minus 2. How do I undo a minus 2? Plus 2. What's 3 plus 2? So n equals 5, which means there's 5 sides. We're going to skip B if you need some room there. name the polygon. What do you call a five-sided figure? Pentagon. Okay. All right, let's try C. On C, again, our sum when we're all done is 25, 20. Again, to get to that answer, I would have to do n minus 2 times 180. So we're just going to work backwards. If I work backwards, what do I need to do first? Divide by 180. So n minus 2 equals, I don't know that one in my head. 25, 20 divided by 180 is what? 14? Okay. And then to undo the minus 2, I would do what? Add 2. So how many sides do we have? What do you call a 16-sided figure? Yeah, it's just a 16. Gone is how you read it, but there's a dash in between. Okay? Okay, last three. Find the missing angle measure in each polygon. Can we handle A? How many sides are we working with? And what do the angles add up to in a quadrilateral? Yeah, and if you know 360, awesome. Hopefully you get to the point where you have that one memorized, or you could do n minus 2 times 180. So I know altogether 360. We can add these up. What do you do if we add those up?
You get 200 and 190.
Okay. So do we agree x plus the 296 has to give me 360?
Yeah.
And then subtract 296. That angle measure has to be 64 degrees. Okay. On B, do you know the sum right off the top of your head? Probably not. So all you do then is plug into n minus 2 times 180. How many sides?
7.
I know, and it looks like 7. If you like picture zooming in, there's a little bend right here. So if we count the number of angles, 1, 2, 3, 4, 5, 6, 7, 8. There's actually 8 sides, which I know is tricky. That's not straight. So 8 minus 2 times 180, which is 6 times 180, which is what? What is it? And then next step, we can take x. Oh, plus 2x. What's x plus 2x? Can I just go 3x right away? And then we add all of these up. And what do we get? So then plus 815 equals 1080. What should I do next to solve? Yeah, can you tell me what you get? 265? And then divide by 3? I say it's not going to be a whole number. What did you get?
88.33.
So 88.3 repeating. Is that fine? You could do 88 and 1/3 if you wanted to. Okay, last one. How many sides do we have? 5. And if you have the sum memorized, then fine, just go to work. If you don't, then you do 5 minus 2 times 180. 3 times 180 is 540. Okay, so I know it has to equal 540. What do I combine? What do I combine? 47 and, okay, so add 47, 119, and 90. What do you get? Yeah, you have two angles that are the same, these two, right? So if I call one x, and I call the other one x? So 2x. Okay, and then minus 256. What do we get? 2. And then divide by 2. Okay, are you alright with that? Okay, I'm gonna grab your homework packets. Homework again, how many problems do you have to do? 8. Okay, and you'll probably finish them in 5 minutes.
Wait, do we need?
Oh, if you watched the video and did a summary, put it in the basket.
Yeah.
Okay, your assignment is this. Are you listening? You can also look like visually. 1, comma 3, so 1 and 3, and then 7 through 12. And I'm just gonna let you try. We can talk tomorrow if we need to. So work for the time that you have left.